industrial activities produce wastes. These wastes have to be stored and disposed of in a way which safeguards our health and the environment. Nuclear power stations produce a lot less waste than oil, coal or gas-fired power stations because they use much smaller amounts of fuel with almost no gaseous emissions. A 1,000 megawatt coal-fired power station burns 2.5 million tons of coal every year. A nuclear power station of similar capacity uses only 25 tons of uranium fuel a year. The waste produced by a nuclear power station can be classified into 3 levels: low, intermediate and high. Low-level waste includes used protective garments, tissues, filters, resins and chemical residues. Intermediate-level waste consists of liquids, solids and components that have been directly used in the nuclear generation process. High-level waste may be isolated from spent fuel after reprocessing. The low and intermediate level waste is first measured, checked and compressed into rust-proof metal drums or reinforced concrete barrels. All 3 levels of waste are carefully checked at every stage of handling to ensure that their radioactivity is well below permitted limits. This is in accordance with international practice and regulations. At Daya Bay, as being shown here in France, the drums and concrete barrels containing low and intermediate level waste will be stored on a temporary basis within the power station site. Later, they will be deposited in a shallow land disposal area in Guangdong province. This is a specially built chamber, carefully sealed and continuously monitored. As in other countries, the government of China strictly forbids the dumping of nuclear waste into the sea. 1/3 of the fuel assemblies in each reactor at Daya Bay will be removed each year. These used or spent fuel assemblies will be stored and monitored for up to 10 years in a specially designed water pool to allow the heat to dissipate and some of the radiation to decay. When the time comes for removal of the spent fuel, it will be placed into heavily shielded containers or casks designed to prevent the release of radioactivity. These casks will be sent to a reprocessing plant to be built in northwest China. The design of the casks and their transportation are in accordance with agreed international practice as recommended by the International Atomic Energy Agency. At the reprocessing plant, the uranium content of the spent fuel can be recycled and used again. This leaves only 3% high-level waste, which is vitrified. It is mixed with a glass-making material, heated to a high temperature, and while still molten, is poured into rust-resistant cylinders. The glass solidifies inside the cylinders, immobilizing the fission products in the process. Each year, the Daya Bay power station produces about 3 cubic meters of high-level waste after vitrification. In France and the United Kingdom, feasibility studies into long-term deep storage repositories are being conducted to allow the waste to be isolated from the environment. Such structures are up to 1,000 meters deep, in dry, stable formations completely resistant to water penetration and free from earthquake and volcanic activity. The government of China is conducting its own surveys and studies into deep, long-term repositories for nuclear wastes. The nuclear waste management system is designed to ensure that nobody is ever subjected to levels of radiation higher than normal background levels. The aim is to protect not only this generation but many more to come.